Thank you all for standing by and welcome to today's webinar, Big IP Terminating Gateway for Consul Connect, an app modernization solution by F5 and HashiCorp. My name is Karen Hui and I'll be helping to facilitate today's webinar. Please feel free to type your questions during the webinar in the Q&A section at the bottom of your screen. This webinar is recorded and the recording will be made available after post-processing, usually 2 days. Our speakers today are Blake Covarrubias, Senior Product Manager Consul with HashiCorp, and Sean Empey, Principal Solution Engineer, Office of the CTO with F5. They'll be talking about service mesh and introduce Consul Connect, the concept of terminating gateway for app modernization, as well as the big IP terminating gateway solution for Consul Connect. Please feel free to reach out directly to the speakers via Twitter for any follow-up questions as well. And now let's get started, Blake.
Okay, thank you, Karen. As Karen mentioned, my name is Blake Covarrubias. I'm the product manager working on Consul and specifically Consul Service Mesh. And so this is just an agenda today for the webinar. I'm going to provide a brief overview of Consul and its capabilities and what problems that Consul can help solve for within a modern networking environment. And then I will briefly touch on the integration that we've built in conjunction with F5, and then hand over to Sean to dive into those details. So to set some context, let's start with kind of a traditional data center environment. In traditional legacy environments, typically applications that were deployed were monolithic applications that were long-lived, that ran on servers for weeks, months, or even years. Within those data centers, you had typically a very well-defined north-south traffic paths for traffic coming in and out of the data center. And so then it was easy to do traditional perimeter-based network security with firewalls and using access control lists to control which traffic is allowed in or out of the environment. But with kind of the migration to cloud, this becomes a little more complex and this model breaks down. In cloud environments, typically the environments are much more dynamic. You no longer have single monolithic applications, but more modular microservice applications, which are running across different runtime environments or in different formats like containers or VMs. In the cloud, you also have a more high amount of east-west traffic between applications because those applications are broken down and now need to communicate amongst each other. And there's no clear concept of a network perimeter as well. And so with that and some of that complexity, what operators typically then look to do is move from this more static model where they're tracking IP addresses for application into a more dynamic service-based networking model. Several of the cloud providers do offer their solutions to allow you to use this more service-based networking model, but these are unique and kind of distinct per the cloud you're running on. And so if you're an organization that actually has a multi-cloud strategy or has a need to connect on-premise environments to multi-cloud, you now find yourself in a position where you're using different solutions to track the service information across these different environments. It's disjointed. And so then the goal kind of becomes, how can you unify this all together and have a common service registry and service discovery across the different cloud or runtime platforms? And so this is what Consul provides at its core. Consul provides a registry for you to register applications which are deployed within your environment, allowing you to decouple the association of IP addresses from the applications. So consumers of this catalog can query, if they want to connect to, say, a web wants to connect to a database, can simply look that service up in the catalog and receive a healthy list of endpoints that are available for that database service. And this allows you then to also transition security from, again, IP address model to a more dynamic logical service model. In addition, Consul will track the health and availability of the applications and services which are deployed. So again, you have a real-time directory which is kept up to date of all the healthy services no matter where they're running. This really is, I want to just kind of repeat this, this really is the foundation of Consul. It is that registry, and it enables the additional capability which Consul can provide, which I'll talk about in some coming slides with regard to service mesh. Consul does allow you, again, it can be deployed across different data center environments. So you have a common discovery layer that can work across AWS, GCP, and Azure. Consul supports data center federation, so you can actually tie these environments together and have a unified way to, from your, say, AWS environment, look up and connect to a service running in Azure or GCP. Some of the benefits, again, of the central service registry model are increased or improved developer agility. It allows developers an easy way to find what's running in the environment and connect to those. Better resiliency for applications that are running within your environment. You can avoid cases where an application is, say, doing a DNS lookup and one of the IPs that's returned isn't not healthy or doesn't exist, and so the application is connecting to something which doesn't exist, so there's a kind of a black hole and retries and timeouts. You avoid that by having that registry always giving you healthy and up-to-date information. They can also in turn help reduce cost as well. So you can centralize on Consul as a service registry and not have to rely on other systems to provide this application data to your services which are deployed. Consul builds on this service registry foundation to also enable service mesh functionality. And so if this term is kind of new to you, what a service mesh is at a very high level, it's a way to secure applications within a microservice environment and provide better load balancing for those applications as they connect to different destinations, and also give you visibility into traffic metrics for those applications and what they're connecting to, like, such as whether an app connects to a remote destination, how many of those requests are being successful, or how many are receiving errors. And the service mesh can track that information and export that to an external monitoring system so that you have a unified way for gathering this telemetry data across the different environments. How this works in a little more detail is typically with a service mesh, you would deploy a sidecar proxy alongside each of the applications that are deployed in your environment. So this, in Consul, is a proxy called Envoy. And this provides, again, that load balancing and telemetry capabilities that I spoke of. It also provides encryption for data between the different services. So when the web service wants to reach out and say, talk to the database, that connection would be routed through its local proxy. That proxy would be responsible for finding, again, healthy and available database endpoints and then connecting to those and would establish a secure communication channel with that remote destination, so the traffic is protected. And then because the service mesh also utilizes mutual TLS, you have a way for the proxies to authenticate each other that they are connecting to a trusted destination in the environment. Consul supports something called intentions, which are all access policies. So this is very similar to the firewall model that I spoke about earlier. It allows you to define in a codified way which applications are allowed to talk to each other in the environment. And so when that connection is established between two proxies, we also do that authorization check. If that connection is allowed, then it'll be forwarded to that destination. But what this gives you, again, is a unified way across different clouds to manage security between applications, as well as authorization policy that typically is different depending on the different platform or cloud runtime environment which you're running in. And so on the previous slide, I mentioned that typically a sidecar, a proxy that's deployed alongside applications. But in some environments, it's not, you're not able to do that, such as if you need to expose a managed service into your service mesh. And so we enable that type of connectivity through what we call a terminating gateway, or really, you could think of this as an egress proxy. What terminating gateways provide is a way for you to register external services or endpoints, whether those be on-prem services or cloud managed services. You register those into Consul and then associate those as being available through that gateway proxy. So when something in your service mesh wants to reach out and connect to the external destination, it gets routed to the terminating gateway using mutual TLS for that security. That terminating gateway checks the authorization policies, which are defined in Consul, to determine whether or not the connection should be allowed. And then if it's permitted, would forward that to that final destination. And so this is really key as organizations are looking to adopt service mesh. You have these applications which will typically, as you're migrating to a service mesh, be outside the mesh, which need connectivity to applications in the mesh and vice versa. And terminating gateways really help you in that migration story, enabling that connectivity for, again, things that are in the mesh, enabling them to reach out and talk to stuff that's outside the environment. And so switching gears a little bit, I wanted to talk about the partnership with F5. F5 is one of the key partners for HashiCorp, and we've built a number of integrations with them across our product line. Such as we can use Terraform to provision and manage the configuration of BIG-IP. And we also have an existing integration today for integrating BIG-IP with Consul for service discovery. So if you're not using service mesh and you just want to be able to leverage that dynamic catalog that Consul provides, BIG-IP can integrate with that and update backend load balancer pool based off of information that's coming from Consul. The next integration that we've built, and what the reason for this webinar today is we've built an integration with to use BIG-IP as a terminating gateway within Consul Service Mesh. And so this allows you to reuse that existing hardware investment that you may have that might be handling load balancing for other aspects of your data center environment and utilize that with Consul Service Mesh. So to talk about that a little more, I'm actually going to hand over now to Sean Empey, Principal Solution Engineer at F5.
All right, thank you, Blake. I'm going to go ahead and share my screen to continue the slides here. All right, thank you. And as Blake mentioned, my name is Sean Empey. I'm a Principal Solutions Engineer in the Office of CTO here at F5. I actually came over to F5 as part of the NGINX acquisition. So spending a lot of time on application delivery over the years here. And most recently, been focusing on these patterns of application modernization. So how do we take existing applications and fit them into more modern architectures? And this terminating gateway use case really fits that perfectly. So to give those not familiar a little bit of a background on F5, it is really a market leader in the application delivery space as well as application security. And if you look at the types of services that we offer for that, it's really the best way to deliver an application in a secure and performant way. And you can see there are a number of features and products that allow us to do that. Now, in order to provide those types of services in traditional environments and cloud modern environments, we need to really support a number of different deployment models. And so, those that have been familiar with F5 know we have, hardware load balancers or ADCs. And so for those that need on-prem data center, high performance, high throughput, those appliances are available. But we've also have virtualized the BIG-IP, so virtual and cloud editions are available. And for more cloud native, as I mentioned, came over as part of that Nginx acquisition. We have Nginx available, all the way to managed services through Silverline, right? So any deployment model really to provide these application delivery services. And in order to deliver those services across those different platforms and deployment models, automation is critical. And so we have ways that we can do that to bootstrap instances of a big IP, no matter where that's running. So cloud templates to be able to do that in the different public and private clouds. Being able to onboard those instances so it has an initial logical configuration when it does come up. And then a way to deploy application services onto those instances of the big IP through our App Services 3 extension, AS3 for short. And then to tie it all together, monitoring and telemetry is critical as well. So we can stream events and logs from the big IP to different analytic solutions. And I bring this up particularly for AS3, the App Services 3 extension. What that is, it's a declarative API. So I can take a JSON object and push that to the big IP, and it will generate the big IP configuration for a given app. And if I push that again with no changes, there's no changes on the big IP. So it's only going to make those delta changes based on that JSON object from that API. And so that's what we're leveraging as part of the Terminating Gateway on the big IP. So Blake gave a really good overview of Consul Connect, how the Terminating Gateway function fits in. And now through this tech preview of the Terminating Gateway functionality for big IP, we can support it as well. And so we've created this Go service that will watch the console server for any changes and generate that AS3 declaration for the big IP, push that to the big IP so that it can handle the requests for the given services that are behind it. And so the critical things that Blake mentioned are, the services, right? So in this diagram, we have Elasticache and Aurora behind the big IP. So we need to register those services with Consul, and this service needs to watch those registrations to make sure we know how to get to that service. The certificates for those services, right? So everything in the service mesh has its own certificate for the MTLS. And so the big IP will take that certificate and perform that MTLS for that backend service. And then the intentions, we have to watch those. And we actually create a data group in the big IP, which is a key value store that we track those intentions so that it's a very fast check and doesn't impact performance. And we can make sure that we're only allowing requests based on what's allowed, based on those access control policies. And basically, I'd like to show you a quick demo to give you a better idea of how this all fits together. And here's a very simple example, right? We have our console server in the middle here. We have a host that's running a micro app and its sidecar. And it needs to communicate with a service that's in an existing application in a data center, and we'll call that app 1. And to do that, it's going to have to travel through the big IP to get there, to terminate that MTLS connection. Now, the big IP TGW, which is the Go service here, as I mentioned, is watching Consul, generating the AS3, and pushing that to the big IP. And this is assuming we have a working existing Consul cluster. And these are the things that we need to configure to add these services in the big IP on. So one, we need to register the service with Consul, right? So this is the name of the service and an IP and a port that it is listening on. And just to show that we can support multiple applications behind a single big IP vServer, virtual server, we have this registration as well. And then we have to register the big IP itself. And so what's different here is it's of kind terminating gateway. And the address and port are actually going to be for the virtual server that it's listening for incoming connections on. And what the Terminating Gateway service does is it creates a single virtual server, and it will use SNI to route the request to the appropriate service behind the big IP. And so now we've registered the services, and we registered the big IP virtual server. So now we need to link those together. So this config entry links the given services to the big IP. So now the console server knows that's how those services can be reached. And I'm going to go ahead and stop presenting here and jump to the demo. And so if we look first at the console server, you can see my services all registered here. I have micro app, I have app 1 and 2, I have the console server, and the big IP. If I click here, you can see these two services are linked services. So the system knows to get to them, I go through the terminating gateway here. I also mention the intentions. So just like ACLs or a firewall, we have a deny all, and then we are allowing micro app to talk to app 1. So next, I am going to go ahead and start my service. And you're going to see a lot of log messages go, but you can tune the log level to only see what you want to see here as far as log messages. And the logs will show each component that it is tracking, the certificates, the intentions, and any changes that it does register. And you can see here it is posting that config, now the AS3 declaration, to the big IP, and that was successful. So I'm now going to go here, which is the host that's running that micro app, and I'm going to simulate a call from that micro app, and it's just going to run a curl to the local sidecar that's going to travel from that sidecar to the big IP to app 1. Let me say, hello, this is a service behind the big IP. So that was successful. So to show a real-time change, we're to go ahead and delete this intention. So next, you can see that we've already generated a new config, and we're in the process of pushing that to the big IP that basically does not have that intention anymore. And since the intention is the only thing that's changing, that's the only, the big IP is getting the full AS3 declaration, but it's just removing that intention from the data group. So now that intention no longer exists. So now I've received a connection reset because this fails at the SSL handshake because we're not allowing that connection through. And to quickly show the big IP, we can see what's actually created here. So what it does, it creates a completely separate partition, the TGW tenant, and it creates this virtual server. And you can see the address and port that we registered are what it uses to create that virtual server, right? So this whole configuration is generated based on what's configured inside console. And we can see there's an I rule that basically checks the intentions, checks the incoming client requesting and where it's the target, and it is looking that up in the data group. And I can show you that. And then it has this policy to do the SNI routing. And we have our two pools, app 1 and app 2, that will be routed to based on the SNI request. And in the data group, you can see now I've removed that string from, or that record from the data group, so no longer exists there. And so that pretty much covers the demo. I'm going to go ahead and hand things over to, actually, before I do that, most importantly, how can we try this out, right? So this is going to be open source code that's going to be available on GitHub on the F5 Dev Central page. And so it will be available at the end of this week. We're just tweaking a little bit more of the documentation, but it is ready to go. And so you'll be able to try that out very soon. And it is tech preview. So we do want to hear feedback and understand how you guys are using this and how you want to use it. And so we will be making updates and incorporating your requests. And I know that Blake and the team over at HashiCorp are they are spending a lot of time adding functions to the Consul Connect and the Terminating Gateway function. So we will continue to keep that up to date and incorporate their changes. All right, over to you, Dan.
Thanks, Sean and Blake, for the presentation. This is Dan Kaleo from Partner License Team here at HashiCorp. I'll be conducting the Q&A session next. This is going to take about 15-20 minutes. We do have some pre-seeded questions to ask the presenters, but we're also going to go over the questions in the Q&A window that you posted. Feel free to take this time while I'm asking the questions to post your own questions within the Q&A window where you see in the bottom of the Zoom session. Let me go back here. Oops. Going back. There we go. All right. So I'm going to run through the first seeded questions for the presenters, and the first one is for Blake. What additional benefits does F5 Big IP bring to existing console environments?
Yeah, so I think one of the biggest benefits that it brings is really, I mentioned it a little bit earlier in my portion of the presentation. A lot of customers already have existing investments in technology like F5, and as they're looking to move to something like Console Service Mesh and adopt that within their environment, they don't want to throw away those existing investments. So it does. This integration does allow you to continue to leverage the F5 investment with Consul. I think one of the really benefits of doing that is that within Consul, most of the load balancer that we use by default is called Envoy. It's a software-based data plane proxy, and so it works well for a large number of applications. But for traditional networking folks, I think it's pretty well known that software forwarding doesn't really perform as well as hardware-based forwarding. And so if you need something that can work at larger scales, something that again interoperates with your existing technology stack, or maybe needs different compliance that might not be offered by Envoy, the F5 can slot in and provide some of that additional functionality.
Great answer. Next question is for Sean. Is the F5 Big IP Terminating Gateway also supported in a Kubernetes environment?
Sure, yeah. So F5 does come from a hardware background, but we've really been making strides into the software space as well. So we've virtualized the Big IP a long time ago. So running in the cloud, running in a VM is supported. Kubernetes, not today, but there are some really interesting things happening around making it available, Big IP itself available in a type of container or Kubernetes environment. But mostly today, with existing solutions we have, Nginx is really the cloud native load balancer, proxy, application delivery controller of choice within F5. But as a terminating gateway function, it can certainly work with that when the service mesh itself is running in Kubernetes and BigIP, basically outside that or at the edge of that application network.
Great answer. Next question is for Sean again. Does BigIP encrypt the connection to backend services?
Yeah, so that is part of the terminated gateway spec. In our first iteration here, we are not adding any encryption to the backend service. And so it's a TCP proxy. We're doing the MTLS between the sidecar and the BigIP. And then basically the protocol from the actual client to the sidecar is what we're sending from the BigIP to that backend service. So in our next update to this software, we will be adding the ability to do MTLS from the BigIP to that backend service. So you'll be able to provide a certificate, a CA to authenticate the service, and then also a certificate so that service can authenticate the BigIP, and then also an SNI name. So that will be supported soon.
Great. And what additional features does BigIP provide these services?
Yeah, that's a good one too. So the BigIP, as I said, is a leader in the application delivery space. So there is a whole host of security and performance features that the BigIP offers, the services you're running behind it. And if I didn't mention it earlier, the way I see this running is these are, SaaS services or existing applications that you're already delivering for other functions or other users. And now we just want the service mesh components to be able to reach out to them. And so this will create a virtual server in front of that. And so you can use the BigIP, the full functionality to deliver that application. And so all this, the security components, performance components, and then basically run this terminating gateway function in front of that. And as HashiCorp extends the functionality of the terminating gateway, exposes more functions, we can then take that and incorporate it into the terminating gateway function to make it more featureful.
Great. Next question for Sean again. Is this solution available today for users who would like to try it out?
Just about. So yeah, as I said, we're tweaking the last bit of the documentation, but it will be available at the end of the week. And the link within the slides shows where it will be available when it's ready. Great.
Okay, so now I want to jump into the questions that have been posted in the Q&A window. The first question from the audience is, will users create new services in BigIP, or will it only update the existing VIPs within BigIP?
Yeah, so it's an important distinction, right? So this will create pools based on the service registrations that are in Consul, and it will create the virtual server based on the BigIP registration in Consul. And so, in this case, Consul is the source of truth that we are generating that whole tenant or partition configuration from. But as I said, most likely, these are services that are already being delivered. So you are, this probably sit in front of another virtual server that you're configuring some other way. And so this will be running on a separate partition. And so it should not conflict with anything that's being done existing on the BigIP. This will just be a virtual server in front of how you're delivering that app today.
Great. And next question is for Blake. Is the Consul Connect available on Windows hosts?
Yes, so Consul itself is available on Windows. It runs on a variety of operating systems, Linux, some of the BSDs, Windows, and even Mac. So it does work across those different platforms. In terms of Consul Connect, really the gap that we have today is in the data plane proxy. So the data plane proxy that we use by default is Envoy within the service mesh. And Envoy at the moment only supports Unix-based platforms. It does not have support for Windows. That is forthcoming. The Envoy community is working on that. They're supposed to have an alpha release that does function on Windows within the coming months. And then at some point that'll graduate to a production status. But that's really the big gap from a production standpoint in terms of being able to use Consul with on Windows, or excuse me, Consul Connect on Windows. I will add though that Consul does have a pluggable data plane model. So we do integrate with other proxies, obviously such as F5, but things outside of that as well. And so it is possible to, if you have a proxy that does run on Windows that you want to use, integrate that within the service mesh and use that for those hosts.
Great. So the third question is for Sean. There's a question about the demo. You presented it, and I think you ran the script. What kind of authentication do we need in the Golang script that you presented?
Yeah, so that's a good question. I can actually show that real quick.
Sure.
So if I exit out of here, so there is a configuration file, which basically has three components: how we're configuring based on console. So in this case, the URL, the big IP, so the URL, the user, and the password. So it does require a password. This can be passed via an environmental variable as well. So you don't necessarily need to put it in a config file. So yeah, username, password, but it doesn't have to be in the config file itself.
Great. And the next question from the audience, do we need to create the virtual server directly on F5, or is it Consul doing it for us the moment we register the Terminating Gateway service?
Yep, so based on those registrations in Consul, that is what is created on the big IP. So the virtual server, the pools, the intentions, everything is generated based on that Consul config.
Great. Next question is, how does a DevOps user determine the intent in the first place? Is there a way to monitor all communications? I think this question is for Blake.
Yeah, so typically the intentions would be defined by the security team, typically within an environment. They have policies controlling what apps can talk to other applications. And so you can use something like Terraform, for example, to define and codify those intentions and then create them within Consul. From a kind of observability standpoint, Consul does have a way to log intentions and traffic within the environment. Today, that is kind of, you would log that at the sidecar level. And so you can get visibility there from each of the sidecars of what connections were allowed or denied based on the authorization in Consul. We are looking at opportunities to centralize some of that information, make it easier to send that off to, say, aggregate the logs and then send it to some external system, so you have an easier way to view the connections that are happening within the system and whether things are allowed or denied. Hope that answers the question.
Yeah, so the next question is for Sean is, will the new big IP configuration always be in a new partition, or can it be in a default one?
So this is always going to be in its own partition, and that's based on a function of AS3, right? So in order to make sure that the declarative config based on that JSON object that's being pushed to the big IP, it needs to basically own that whole tenant. And then once, if you make a change manually, then it will be overwritten by the next declaration. So we do need to keep those separate.
Okay. Next question from the audience. Does this feature work in reverse, a service external to the mesh accessing services inside the mesh via the F5 terminating gateway? This is for Blake.
Yeah, so for that reverse traffic flow, really what you're describing is more of an ingress flow. And so Consul does provide its own ingress gateway to enable that type of connectivity. It also integrates with third-party gateways if you want to use something different than what Consul provides, again, which is Envoy. in terms of working like using this with F5, I think that is another opportunity that we're exploring. Maybe I'll let Sean speak more to that. But potentially we could enable that type of integration as well, so where F5 is handling both ingress and egress traffic flows.
Yeah, I think that's something that would be relatively straightforward for us to add. So I think that if that's something that you folks online here would see as valuable, please let us know, because we want to build solutions that you guys want. So yeah, that's very feasible for us to add that.
Great. Next question is for Blake again. Since this is an MTLS, any feature support for UDP?
Yeah, this is definitely something that we're looking at. So Envoy very recently landed stable support for UDP. In the past releases, UDP support was alpha level quality, but that's recently stabilized. There are some additional things needed to be able to support UDP as a protocol within console service mesh and also support that encryption between endpoints. But that's an area we're looking at. We do have other customers and other users that have expressed interest in that. So I would say just keep your eye on our product announcements and releases. Hopefully that's something we would gain support for over time.
Great. I think this wraps us for today, and we don't have any more questions. Karen, over to you.
Actually, Dan, I think there's one more question in the Q&A.
Oh, here we go. Yeah. So the terminating gateway concept can the terminating gateway concept essentially be used to replace functionality offered by the Envoy proxy?
Yeah. So the answer is yes. The terminating gateway is more of a logical higher level construct within console, and then you can use any number of data plane proxies underneath that to act as a terminating gateway. So the options today are Envoy and Big IP, but as I mentioned, console does support a pluggable proxy model, so you could integrate something else as well. But yeah, you have options on that front.
Great.
And you can deploy both within the environment. If you have a use case to have F5 handle egress traffic for some part of your data center, you can register some services with that gateway and a different set with Envoy-based terminating gateways.
Yeah, makes sense. And before we wrap up, I just wanted to add, just a couple things. So I quickly showed a config file and just wanted to mention that is basically could be any of the major formats, right? Could be YAML, HCL, TOML, JSON. So whatever format you prefer, you can use the config file or can use environment variables to configure it. And this will be able to be run directly or in a container. So we'll provide the Docker file for that as well. So the idea is to make this as flexible as possible for you guys to run in your environment.
Thanks, Sean and Blake, for answering these questions. So this wraps up the Q&A session for today. I'm going to pass it over to Karen Hui to wrap it up. Thank you.
Thanks, Dan, and thanks, Blake and Sean, for a great session. And thank you to our audience. Those are some great questions there. So I hope everybody enjoyed today's webinar and has a better understanding of the big IP terminating gateway for Console Connect. And finally, as mentioned at the beginning, this webinar was recorded and we will make the recording available after processing. I'll send an email out to everyone who registered with the recording link. Have a great day. Goodbye, everyone.